Alright guys, we're going to cover topic 1, section 7, and this is our absolute value equations and inequalities. At the end of this, you will be able to write and solve absolute value equations and inequalities. We've done inequalities, we've covered equations, we've put equations and inequalities together during the last lesson. Now we're going to talk about absolute value. Our new focus here is going to be solving absolute value equations and inequalities. So the most important question of today is, why does the solution for an absolute value equation or inequality typically result in a pair of equations or inequalities? My very next slide, we're going to get into that. We're going to do a lot of work on a number line, because I think if you can visualize it on a number line, you'll do much better in understanding why we have to break the absolute value into two separate equations or inequalities to find both values that will make it true. But before we do that, we're going to jump back to 1.6 when we did compound inequalities. If we had done the lesson in class today, block 2, your bell work, which is where we kind of were when the pop quiz came out, was to look at this question, break it down, and answer it. So let's switch over, and we have, you are training for a long distance cycling camping trip. So we're going to spend some time riding our bike, and we're going to camp along the way. You plan to take 7 days, so that's my first key right there. I'm definitely going to want. Come on. So we want to take 7 days. I'm going to go ahead and put that in brackets because I know that's going to be important to complete the trip. So you have 7-day limit to get it done. You're planning a route with an optional 49-mile loop on the third day. I'll be honest, this seems like extra information. What I do, instead of just putting it in brackets, I'm going to put it in a box, because that's something that may be important, but I'm not sure yet. And what I'll most likely do is, once I finish reading this question, if it is important, I'm going to leave the box open so I can still see that. If it's not, I'm just going to scribble over it, because that third is going to mess with me a little bit, right? It's a number, and I might keep drifting back towards that, trying to say, why haven't I done something with this? Did I forget to fit this in somewhere? We don't want that to happen. So we're going to make a judgment once we finish reading this on whether or not the third day has any factor or play in what we're trying to solve for. All right. So this would put the total mileage of your ride somewhere between. There's another huge key word here. Somewhere between. That means I'm going to be on a lower end and a higher end for this trip of mileage. This right here, this somewhere between, is a huge indicator that we're going to have a compound inequality. And that's because what it's looking like is we're going to have to consider that optional 49 miles. We're going to have a minimum distance to complete this trip, and then we're going to probably end up adding that 49 miles to have a longer distance for that trip. Right now, this is kind of showing me that on the third day may not actually play a part in it, because it doesn't matter where we add those 49 miles. The lesser or greater amounts are just based on the 49 miles. If we do it on the first day or the 7th day, that shouldn't matter. So the total mileage of your ride should be somewhere, or would put your ride somewhere between 756 and 805 miles. How many miles must you average per day? Per day, the word per to me means, well, to all of us means to multiply, right? Miles per hour. How many miles do you cover in an hour? Or if you get driven the car for 2 hours at 60 miles per hour, 2 times 60 is 120 miles that you've covered. To complete either option in 7 days. Again, 7 days, huge point. So I'm going to write down all the relevant information. We have 7 days to complete this trip. This was something extra that maybe they were hoping you focused on too much, but it doesn't matter what day I add the 49 miles. So I want 7 days, and then my shorter trek. Sorry, I was going to say it, but I decided not to. My shorter trek on this camping trip would be 756 miles, and if I choose to do the extra 49, I will have 805. Double check to make sure that's right. That is 49. Okay, I'm doing that because I may catch a mistake in the question, or I may do this and realize 805 minus 756 isn't 49, so maybe I misread something. So I've done this just to check to make sure there's a 49 mile difference between my lower end mileage and my higher end mileage. Now, to complete the 756 miles, I would have to ride 756 miles. Now, I could have some unplanned stops, so I'm going to put my X, which is the number of miles per day. Where is that at? How many miles must you average per day? That's my X. And that's going to be, at minimum, greater than 756. Could be equal to, if everything plans perfect. Rarely happens. You have to make an extra stop. You make a wrong turn. I'm famous for that. So, and then, ideally, I have a 7-day limit. I do not want to go over 805 miles if I add the 49 miles. I'm doing this for 7 days, and I want to know how many miles must you average per day. So that's going to be my indicator that I'm doing 7 days times the number of miles I must do per day to meet these two requirements. So this is a pretty straightforward compound inequality. First thing that I'm always going to check, I'm going to be dividing by 7. I can see that that's not a negative 7, right? We always check to see if it's negative to flip the signs. It's not. So this is going to be a very straightforward 756 divided by 7 will give me 108. So that means on my shortest day, or every day, my shortest day can only be 108 miles. 7 divided by 7 is just X. And here it's going to be, what's that, 115. Oh, definitely did that wrong. Yeah, 115. So if I take the optional 49-mile loop, I'm going to have to maintain 115 miles per day. If I am out there, day 2 was rough, day 1 was rough, I don't feel like I can do that extra 49 miles that day. I'm going to have to average 108 miles per day. So, does this answer make sense? I'm going to show you a way to check it. If I take this number minus this number, and then I multiply it by the number of days I'm on the bike, if I get that extra loop, I've done this properly. So 115 minus 108 is 7. So if there's a difference of 7 miles per day for 7 days, per again means multiply. 7 miles per day for 7 days gives me 49 miles. Because 49 is equal to 49, that would be the additional distance to add the loop. We've done all of this properly. All right, let's clear this and then switch over. See what is up next on our PowerPoint. So, what is absolute value? The absolute value of a number is simply how far from 0 it is. On a number line, we have, this is a real number line. We have 0. We have a wavy number line. And let's say we have a negative 5 and a positive 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, how far it is from 0. On a number line, the number 5 is 5 units from 0. So, I start at 0, and I count to my right because it's going towards positive 5. That's 1, 2, 3, 4, 5. So I have moved 5 units to the right. So the absolute value of 5 is 5. Now, on a number line, the number negative 5 is 5 units from 0. Let's look at what that actually means. So graphically, starting at 0, I've gone back 1, 2, 3, 4, 5. So I am 5 units. Again, I've moved 5 units to the left to get to negative 5. So negative 5 is 5 units from 0, as well as 5 being 5 units from 0. What does that mean? Well, the absolute value of 5 or negative 5 is equal to 5 because of their distance from 0 on a number line. if I gave you, oh, there we go. If I asked you for the absolute value of negative 12, you would move 12 units to the left on the number line, which would then just be 12. So the absolute value of a negative number is the number in its positive form. The absolute value of a positive number is its value in a positive form. Nothing too big here. In a minute, we'll start doing the equations and inequalities with them, and we'll see why this is important to know. So now we're going to do it with variables. And when we talk about a variable, that is a placeholder for any number. We use x typically. We're going to use x in this class most often. Sometimes we'll have y. In a little bit, we're going to get into other types of function notation, and it'll be a little bit different. But x can be any number. So if I said x is equal to 12, let's write it. Get you guys ready for geometry. If x equals 12, then the absolute value of x is 12. That makes sense, right? 12 is 12 units from 0, so the absolute value of 12 is 12. Now, if I just said this, let me see if we can make sure we're not skipping the PowerPoint. Now, the problem with this right here is there is another number that satisfies this equation, right? The absolute value of x being 12. Well, what if I put negative 12 in here? Let's make that a little bigger. If I put negative 12 in there, isn't that also 12? So when I do absolute value, I have to break it up into a positive version of what's on the right hand side or on the other side of the x and a negative. So what we're doing here is I have the absolute value of some unknown number is equal to 6. Once I break these up into standalone equations, I can say x is equal to 6 or x is equal to negative 6. So I'm going to drop the absolute value bars, and I'm going to put everything on this side, one version in positive, one version in negative. Let's see it again. The absolute value of some unknown number is 21. I can rewrite this with x. Oh, come on, how do I pick the same color? I can rewrite this as x equals 21, dropping the absolute value bars, or I can write this as x equals negative 21. If I plug x in, here I get the absolute value of negative 21. That is in fact 21. Here I plug in x is equal to 21. The absolute value of 21 is also 21. So we're going to break these up, drop the inequalities, drop the absolute value bars, and we're going to get two values here because both of these make this true. So on the next slide, we've got the answer up already because just like I said, or I would have said in class, we have this equation right here. The absolute value of 2x minus 7 is equal to 11. Now you can see that the solution set, or the answers, that's another way to say answers, is 9 and negative 2. So what we're going to do is we're going to recopy the expression. It was 2x minus 7 equals 11. This is what I'm starting with. Now I'm going to drop my absolute value bars. I'm going to rewrite this as 2x minus 7 equals 11. And I'm going to write this as 2x minus 7 equals negative 11. Because just like in our previous example, the value inside here can be negative 11 or it can be positive 11, because either way, I was going to say magnitude. Magnitude is another word for absolute value or length. The magnitude or absolute value of this can be negative 11, because then I'll take the absolute value of negative 11 and I'll get 11. So we're going to solve for this. Add 7 to both sides. 2x is equal to 18. Divide by 2. X is equal to 9. Here I can add 7. 2x is equal to negative 4 divided by 2. X is equal to negative 2. So if I asked you what numbers satisfy this absolute value expression or equation, we can test that by plugging in this. And what I have here is 2 times 9 minus 7 absolute value is equal to 11. 18 minus 7 is equal to 11. The absolute value of 11 is in fact 11. Here I can do 2 times negative 2 minus 7. So these are supposed to be absolute values, so let's do that. And then I'm going to put equals 11. Remember, I'm testing the original. 2 times negative 2 is negative 4 minus 7. Absolute value is equal to 11. Negative 11 absolute value is equal to 11. So we've done that right, and we're able to check it. All right, so 9, negative 2. All right, like I said before, your EOC will mostly be word problems. Obviously, I've never seen the EOC before, so I'm not allowed to, but what I am basing this off of is I go to Barnes & Noble with my kids or the library, and one of the first things I always check for are the EOC, Algebra 1, and Geometry guides. The study guides that some of your parents may be going out right around midterms to have you guys start studying. And what I've noticed in them is a majority of them focus primarily on word problems. Now I'm going to assume Barnes & Noble is going to stock the books that are the most helpful, and by word of mouth, oh yeah, I used this book, I passed the EOC, I did great, so people come and request it. So they're going to stock the books that most accurately reflect the EOC. So if they're using a lot of word problems, we're going to use a lot of word problems. It's better to be over-prepared than under-prepared. So the members of the debate team are traveling to a tournament where they will stay in a hotel for 4 nights. The total cost for each member must be within $20 of $175. Which of these hotels shown can they consider? What does that mean? So they're going to stay in a hotel for 4 nights, and the total cost for each member must be within $20 of $175. So in 4 nights, they want to spend $155 or $195. No more, no less, right? They want the amenities of a little bit more expensive hotel, but they don't want to break the bank trying to find that hotel. So in color here, the difference between the total cost and $175 is less than or equal to $20. What is the difference between the total cost and $175? So the total cost would be 4 nights at X number of dollars minus $175. The difference, we have difference, this is our difference symbol, between total cost, so they're going to be there for 4 nights, and that's the cost per night, is less than or equal to, that's our symbol there, because we want to be within that $20 plus or minus the $155 to $195 range of $20. So we're going to simplify this to be 4x minus 175 is less than or equal to 20. Just like we did before, we're going to drop these absolute value bars, and everything on the right where my x is not, one side's going to be positive, one side's going to be negative. I'm going to move the 175 over by adding 175 to both sides. And I'm going to have my 4x carried down. 20 plus 175 is 195. I'm going to divide both sides by 4. Notice my sign does not change because this is not a negative 4. So if we're dividing by a positive number, our signs stay the same. The 4's cancel, and 195 divided by 4 is $48.75. All right. Now this one, the minimum cost, that's why we're negative now. I'm going to do the same thing, add 175 to both sides. But this time, because I have negative 20 plus 175, that's going to leave me with 155 divided by 4 again. Again, it's positive 4, so the signs don't change. 155 divided by 4 is $38.75. So our cost needs to be between $38.75 and $48.75. Now let's go back and say which hotels can these teams consider. Remember, we're between 38.75 and 48.75. So 38.75 is over here. Imagine this is a number line. 38.75 would be right about here, and 48.75 is right about here. So the hotels between those two spots on the number line are Hotel A and Hotel B. Let me bring this in so you can visually see what I mean by on the number line. There we go. Switch over. So our first number was, I had that upside down. So here's our number line. Say 0 is here. This is $40. This is $45. This is $50. 38.75 would be here, and 48.75 would be here. So Hotel A and Hotel B are between our lower limit and our upper limit. They don't want to spend less than 38.75. They don't want to spend more than 48.75 a night per person. So we can now say with confidence that Hotel A or Hotel B fit their price range. Hotel C is just a little bit out of their price range for each person per night. So go ahead and pause the video here. This is our concept summary. Remember, when we're graphing these, an equal sign is a closed circle at the number that we're set equal to and nowhere else. Now here, I'm actually going to pull this one, and we're going to do that one next. But just remember, equal sign is a single point on the number line. But because we had the absolute value bars, we got to 9. We got to have a -9 and a +9. Solve for it. We get 8 and 26. That's why we have that. Here, we have the absolute value of x is less than or equal to 1. So we can get x is greater than -1 and x is less than or equal to 1. And that's what this would look like on our graph. Right? It's in between -1 and 1. This is like our hotel problem. And then this is kind of the opposite. The absolute value of x is greater than 2. X is less than -2, or x is greater than 2. Here's our -2. It's open because this is not a greater than or less than sign. It's strictly less than. So we do not include 2 in our answer. And it continues to the left forever. Here, x is greater than 2. Open circle again because it's strictly greater than, and it goes off to the right. Let's do this one real quick, and then we're going to swing back around to the one in the concept summary. Alright, so let's paste it in here. So now, this is something that we didn't cover, but this is something that you do need to know. When we're in class, I always tell you, we want to get x by itself. And I always say the first thing you have to do is always start with what's furthest from x. I have a minus sign and an 8 here, so that's the closest thing to x. Then I have the absolute value bar, then I have +3. This right here is the furthest thing from x. So I'm going to slowly work my way towards x by chipping away at everything else. So the opposite or the inverse operation of addition is subtraction. So I'm going to subtract 3 from both sides. X minus 8, still maintain the absolute value bar because we're not doing anything with that yet, is equal to 8 minus 3, which is 5. Now we're going to split off into our two equations. One of them, and this is where we drop our absolute value bars. Our first one is x minus 8 is equal to 5. And our second one is x minus 8 is equal to -5. Because here, the result of both of these equations is going to give us a number that will force everything on the left be the same distance from 0 on the number line. So here I'm going to add 8, x is equal to 13. Here I'm going to add 8, x is equal to 3. How do we test it? Let's plug it in. 13 minus, so I'm going to plug in this 13. So this x is substituted for my first one, which is 13 minus 8. Take the absolute value, then add 3, and we should get 8. 13 minus 8 is 5, plus 3 is in fact 8. So we've done that part right. Now let's check the second one. Again, x minus 8 absolute value plus 3 is equal to 8. This time I'm saying x is equal to 3. So 3 minus 8 absolute value plus 3 is equal to 8. 3 minus 8 is negative 5 plus 3 is equal to 8. The absolute value of negative 5 is 5. 5 plus 3 is 8. 8 is equal to 8. So my solution set is French bracket, because we always do our sets in those types of brackets. Mine don't look particularly okay, but then we're going to write them in ascending order. 3 and 13 are the two solutions to this equation. Now, let me go back. All right, let's look at this one. I am going to mention two student names because this year they've been on top of everything. As soon as I say I go to teach something, they either already know it or they'll ask me the question that I'm going to ask them. They've been really impressive this year, and I know they came into the year kind of worried about how they were going to do in the class. So I want to point out, when I say their name, it's not because they did anything wrong. They did what seemed like the normal flow of operations here that we would always do. I just showed them a shortcut, and they both were really excited about how to do this. So Patrick and Patricia, if you're watching this, you're doing great in the class. Keep it up. And here's that shortcut I showed you in block 3 that hopefully block 2 will like. So when I asked them, they said let's distribute first, then we can drop the absolute value bars, and then we can do the positive 18 and the negative 18. Now, what I wanted to point out was this 2 is outside of the absolute value bars. So what I can do there is I can go ahead and divide this by 2, because this is the same as 2 times that. Now this will cancel here, and then 18 divided by 2 is 9. I have x minus 17. Now I'm going to retain the absolute value there, because all I've done is simplified out that 2 by dividing by 2. And now here we have a much easier problem to work with, and I can drop my absolute value bars. I'm going to have x minus 17 is equal to 9, or x minus 17 is equal to negative 9. Here I'm going to add 17 to both sides, and I get x equals 26. Here I'm going to add 17 to both sides. That's not a 17, that's a pi symbol, sort of. So the difference between negative 9 and 17, this is the same as doing 17 minus 9, and that's going to give me 8. So my x here is 8. Now let's test and see if we've done it right. I'll admit, because I don't mind doing it, when I did this a minute ago, I miscalculated this portion, and I've now had to go back and do it a second time. So let's check it, because we should always check it. I'm going to use my original equation before the simplification. I'm going to have 2 times the absolute value of x minus 17 set equal to 18. And I'm going to plug in for x equals 26. That's going to show me 2 times the absolute value of 26 minus 17 is equal to 18. This is 2 times the absolute value of 9 is equal to 18. 2 times 9 is 18. So this one is correct. This one's true because 18 does equal 18. Now let's do 2 times the absolute value of x minus 17 equals 18. And I am going to plug in x equals 8 this time. So 2 times 8 minus 17 is equal to 18. Let's see if that's true. 8 minus 17 is negative 9. I have 2 times that is equal to 18. The absolute value of negative 9 is 9, so I really have 2 times 9 is equal to 18. And since I'm running out of room, 18 is equal to 18. So your goal here for this example and the one with the 3 over here is to get first your absolute value portion by itself, then drop the absolute value sign and split your answer here, 1 positive, 1 negative, and then solve for it. Alright, did that. We did get 13 and 3. We've shown that that was true. Let's look at this one. 6 times the absolute value of 4 minus 8x is equal to 30. Oh. Alright, so let's look at this one. We have our 8 our x is here, so we want to go to the thing furthest away from it. So that's going to be my 6 times this value. So the first thing I'm going to do is divide everything by 6, and that's going to leave me 4 minus 8x equals 5, because 30 divided by 6 is 5. Now I can drop those bars, and I have 4 minus 8x equals 5, or I have 4 minus 8x equals negative 5. Now, this is a little weird. Usually we see the x's first or whatever, but this is just the constant 4, or positive 4. So to undo positive 4, we're going to subtract by 4 from both sides. And that's going to leave me 8x, because these will cancel. And 5 minus 4 is 1. Now we're going to divide by negative 8, because we want to get rid of that and that. That's going to leave me with x is equal to negative 1/8. Fractions are fine at least. That's why I wanted to do this one. Don't panic if you see a fraction. Perfectly fine to have a fraction. Now again, here, subtract 4 from both sides. This gives me negative 8x is equal to negative 9 divided by negative 8. X is equal to, now I have a negative and negative, so that becomes positive 9 over 8. So my solution set is negative 1/8, comma, 9 over 8. Close my bracket. So let's see what our solution is. Yep, negative 1/8 over 9 over 8. All right, that is the end of the PowerPoint. Block 2, if you're watching this. When you come in the room, put your phones in the holder on the wall, start the bell work. We have 3 or 4 minutes where I take attendance, and then at that point, I should be able to say, all right, I'm going to call on somebody. I'm either going to do it random, volunteer, and you're going to come up and we're going to work on it. If I randomly call you and you don't know how to do it, that's fine. You just kind of give me that look and I'll know what that means. And what I'll typically do then, and I've done it so many times in class, I've just never pointed out that I do it, is I'll say, okay, I just want you to go up there and write. And that's all I'm asking you to do. I want you to go through the motions, right? Because you were picked at random by the generator. So if you can't do it, there's no penalty for that. You just go up, and then I'm there. You have your classmates who are there to help you with it. Don't panic. We're not setting you up for failure. The other thing, if I'm talking, or if someone is talking, answering my question, talking over them, holding side conversations is not okay. It's very rude, very disrespectful. And today, I did try 3 times to start talking about the bell work. After warning, I raised my hand signal. I said, all right. I made eye contact. I called out a couple names, and none of those were a deterrent or a stop to talking over me. And that is what ended up with us being in the pop quiz situation. For all the time I've been teaching, tutoring, going to schools and working, like even my daughter's schools, I've never given a pop quiz. It's never been to that point. Alright, you've got your test on Monday. I've done some of the homework problems right here on the screen for you. If you have any questions, leave them in the comments here, or private message me on Edsby, and I will get back to you this weekend. I will be at the cross-country meet first thing in the morning out in Dunedin. And I'm going to take my daughter over to the beach for a while, and then I'll be back here doing some other videos and answering your questions. If we got a lot of questions, then I won't be making many videos tomorrow. All right, we'll see you guys on Monday.